Okay. So, what is the basic meaning of a resonance? Prasanna, what is resonance? Priyanka, what is resonance? If anyone will ask you what is resonance, then what you will say? Yesterday only I told you what do you mean by resonance. If anyone will ask you what you will say about resonance. Yes, just answer it. Resonance is
So,
what?
when we have a resistor, inductor, and capacitor, the value of the inductor and capacitor will cancel together and we get the pixel
Yeah,
just an
that
R value.
okay. So means you
One
have to.
F equal to 1 by 2 pi and root of LC.
Huh. So this condition is happening at what condition? When XL is equals to XC.
XL equal to HC.
Yeah. And you have to say like when your voltage source and current source will be in phase.
Are in phase.
It's a very simple definition of a resonance.
Yeah.
When a voltage phase and a current phase will be in a phase, that circuit is known as a resonance. In that circuit, there should be a presence of a resistor, there should be a presence of an inductor, and there should be a presence of a capacitor. And inductor and capacitor will both cancel each other. And the value will be cancel each other, and you will get the frequency value is 1 upon 2 pi root under LC. It is in hertz, and if anyone will ask you in a radians, then what you will say, omega is equals to 1 upon root under LC. Is this clear?
Yes, sir.
Okay. So yeah, we had discussed resonance and all. Okay. Now we are moving forwards. Means we have to take a definitions. Okay. Some definition was left yesterday, so I will give you some definition. Just write it down in a notebook. Okay. So let me check it. What the things is left. Quality factor I discussed. No, no, no. Quality factor I didn't taught you yesterday.
No, sir.
Okay. Write it down. After that, should write it down. First point, for omega lesser than omega naught, the capacitor reactance Xc will be greater greater than the inductor reactance XL. Okay, that is XL is lesser than XC. Okay, for omega is lesser than omega net, the capacitor reactance will be greater than the inductor reactance, that is XL is lesser than XC, and the net reactance is capacitive, and the net reactance is capacitive, is a capacitance, it's a capacitive, I'm writing is a capacitive in nature. So therefore the current I leads the applied voltage V, and hence the power factor is leading in nature, and hence the power factor is leading in nature. Okay, at omega is equals to omega naught, what was happening? The capacitor reactance is equal to inductive reactance. Equals to inductive reactance, that is Xc is equal to XL, and the reactance is 0 is 0. Okay, the reactance is 0, and therefore the impedance is purely resistive. Impedance is purely resistive in nature. Okay, and here what you will get, Z minimum is equals to minimum impedance value you will get. Minimum impedance value you will get, that is Z minimum is equals to Z R. So write it down. Therefore impedance is purely resistive, and Z minimum is equals to R. As the impedance is purely resistance, as the impedance is purely resistive, the current will be in phase with voltage. The current will be in phase with voltage. Okay, and power factor will be 1 or unity power factor you will get. Okay, now so for omega is greater than omega naught, the capacitor reactance Xc will be lesser than the inductor reactance XL. So that is XL is greater than Xc, and the net reactance is inductive. Therefore,
Lagging.
yeah, it is a lagging power factor. Therefore, it's lagging load. Lagging power factor, or we can say current lag voltage by some angle phi. Okay, so now variation of a voltage across inductor and capacitor with respect to frequency. Right, the next topic. Variation of voltage across the inductor and capacitor with respect to frequency. Okay, so first point, the voltage of inductor, right like this, the voltage across the
Sir,
inductor.
in previous points, what is the difference between omega and omega naught?
What was? Yeah,
Omega and omega naught.
omega and omega naught. See, omega naught means 1 upon root under LC. Okay, okay. So, like, see, suppose you have a frequency that is 5, 5 Henry, and here it is capacitor is suppose it's a 25 microfarad. Okay, so the value of this 1 upon 5 into 25, you will multiply, so you will get some value. Suppose you are getting 100 hertz 100 radian. Okay, so this is omega naught, and omega is what are the supplying frequency we are supplying. Okay, what frequency we are supplying. So it
It's
could,
just like an input and output, right?
yeah, it's just like a
Omega is the input, omega naught is the output. What the answer we
yeah,
are getting.
yeah, that's what, it's not a, it's just a input, means the input frequency what we had given. Okay, it's just a
Yeah.
input frequency what we had given. What it, it's nothing but
Got
it's just a input frequency what we had given. So this is omega and omega naught, it's not a very big thing. Okay, so I hope you understood. uh, so now what I'm asking now, variations of voltage across the inductor and capacitor with respect to frequency. So what will happen when you will get the voltage across the inductor and capacitor. Okay, so the voltage across the inductor and capacitor will be same at resonant frequency, at omega naught, that is resonant frequency. Why so? Because XL is equals to XC, and voltage means what? V is equals to I into XL, and voltage V of L, it's, I'm talking about the magnitude part. Okay, and VC will be I into XC. If these values are same and both, and we having a current in a series, so this voltage will be same only, because these magnitudes are same, right? So what's happening here now, V is equals to I into XL. I'm talking about VL, and VC will be I into XC. If we'll talk about the angle, so you will get VL is equals to J I XL, and VC will be minus J I XC, because XL will have 90 degree and XC will have minus 90 degree. That's why minus J is came. So this is same, this thing is same, this current is same, this current is same, the value will, the magnitude will be same only. So VL, what you are getting VL, I'm taking V dash at an angle 90 degree, and here what you will get V dash at an angle minus 90 degree. So magnitude, see the magnitudes we are getting the same. magnitude we are getting the same, but the angle is out of phase. Okay, so will be same at omega naught, means magnitude will be same, magnitude will be same, but angle, but yeah, but both will be opposite phases, but both will be out of phase. Out of phase we can write, out of phase means opposite phase, so it's 90, so it's minus 90. Okay, therefore net reactive voltage is 0. So suppose 90 degree is going, V dash is going upside. If I am having V dash at an angle 90 degree, this is my reference, and V dash minus 90 degree, so it's getting down. So here you have 90 degree, and here we have minus 90 degree. So this is positive axis, this is negative axis, so both will cancel out and you will get 0. You will get 0. So this positive and this negative will get cancel out and you will get 0 value. Okay, so voltage is 0, therefore the net reactive voltage is 0 and infinite supplied voltage appears across the resistor. So voltage will be appear across only across the resistor, not in this reactance. See, one very good question is that at resonance, write it down, it's a very important point and remember this point. So at resonance, at resonance voltage across the inductor and voltage across the capacitor may be higher than the supply voltage also. Okay, at resonance, the magnitude, I'm talking about the magnitude of the voltage across the inductor and capacitor is equal and it can be greater than the applied source voltage, and it can be greater than applied source voltage. I will give you how. Means you are applying 5 volt and you are getting more than 5 volt, how it can be possible. So suppose you are having R network, RLC network, and this is your C, and you are giving a supply with 5 sine 5t. So what is omega? This is your omega, and you have 5, this is your, I am taking this as a 5, and I am taking this particular is also 5. So what will be the resonance frequency? 1 upon root under L into C, 5 into 5. So omega naught is equals to 1 by 5, right? Omega naught is equals to 1 upon 5, or yeah. So if omega naught is coming as a 1 upon 5, omega naught, this is your resonance frequency, this particular is your resonance frequency. So what is the magnitude of this? This is 5, means in terms of RMS, 5 by root 2 you will get at an angle 0 degree. So this is your applied voltage. Okay, and what current you will get? I will be, because at resonance frequency this will get cancel out, so you will get 5 divided by 5 root 2 only. So this will get cancel out, you will get root 2, right? You will get root 2 at an angle 0 degree only. Okay, so what I am telling, so if you want to get the value of this XL, this particular XL is omega into L, right? So if you will substitute the omega means we are talking about at what frequency, we are dealing this at resonance frequency, so it's omega not L. Okay, we are dealing it at the resonance frequency. Okay, so better means this is my omega, but I am operating this at a 5 sine 1 by 5t. I am operating at this frequency. Okay, so that's why the omega value I am taking as 1 by 5. Okay, so I am operating means I am applying the source means think like I am applying the source as 5 sine 1 by 5t. Okay, so the omega value is 1 by 5 and omega naught value is also 1 by 5, so omega is equals to omega naught we are getting, that's 1 by 5. So in this case if you substitute the value, what you will get, omega naught value is 1 by 5 and L value is 5, so you are getting 1 only. Okay, and 1 into root 2, 1 into root 2, so 1 into root 2, so you are getting root 2 voltage, j root 2, and here you are getting minus j root 2. Okay, so 5 divided by root 2 is greater than, although 5 divided by root 2 is greater than 5 divided by root 2. So here the case what we want, it's not possible. Okay, now we take the another case. See, this value what we are getting, 3.52. Okay, and 5 this is root 2 value, root 2 value is 1.4, 1.414. So although these particular 2's are smaller than this, but now if we'll change the circuit, if I'll take a different circuit like this, I'm taking, this is my L, this is my C, and this is my applied source, applied voltage. So I am taking now 1 sine 1 by 5t. Okay, I change the value, so applied voltage, I change the value, and this I had assumed this is my, this particular what we have taken initially 5 only, na? Okay, so just wait guys. Yeah, so guys, now assume it is 1 and this particular is this particular, and if you will convert this, what you will get, Vm by root 2, 1 by root 2, you will get 1 by root 2, And what is the omega naught frequency? And this is assume this as a 5, this particular as a 5 only. So you will get omega naught value is 1 by 5 only, while substituting a value is 1 by root under L into C, that 5 into 5, you will get 1 by 5 only. And this get cancel out, so current you will get V is equals to IR. So V is equals to IR. So current, how much you will get? 1 by root 2 divided by R, because this both will get cancelled out. So 1 by root 2 current you will get. 1 by root 2. Okay. So, and now if you will substitute this particular in this particular, so see, so 5 omega, so you will get how much? 1. This will be 1. And current is how much? Current is, we are getting current, so VL is 1 into 1 by root 2, and VC is 1 into 1 by root 2. So see, so it's, if you will write in terms of a phase, so J by root 2, J by root 2 will come, and here minus J by root 2 will come. See the magnitude. So magnitude means we are getting the magnitude is equals to the supply voltage. See, the magnitudes came up to the supply voltage across this potential only, 1 by root 2 at an angle 90 degree, 1 by root 2 at an angle minus 90 degree. So by changing like this may be high, this can be, means it's depending upon the frequency, at what frequency you are tuning the circuit. If this could be 50 volt also, and this could be, if it will be 50 volt, it will be 50J, so it will be minus 50J, so both will get cancelled out. It's depending upon the frequency, what frequency we are setting. Okay, so that's why voltage across the inductor and capacitor may exceed the supply voltage, like what we did now. Is this clear? Prasanna, is this clear?
Yes, sir.
Okay. Priyanka, for you, is this clear?
Yes, sir.
Okay. Now, let me draw like, so this is your V. I'm drawing for VC. Okay, I'm just drawing for VC. Okay. When both are matching, when this is your VC, maximum voltage of capacitor, this is your maximum voltage of inductor, when both are intersecting, when both will intersect at resonant frequency, I'm writing F0. This is your FC capacitor, and this is your FL capacitor. This is your frequency. This particular is your Okay. So what is the meaning of this? Means see, if you will have a zero frequency, if you will have a zero frequency, so what is XL? XL is omega into L, right? And omega is 2 pi f into L. So if you have a zero frequency, if you substitute zero, so XL is becoming zero. So voltage will be become zero only, no? That's why I'm starting from 0 for FL. In case of FL, if I'll put the F value is 0, so we'll get 0. Then if I'll increase the frequency, if I'll increase the frequency, so some frequency it will get increased like this. Okay, it is getting increasing. My voltage is getting increasing. So at some point it will come, it will exceeds its limit, means at maximum point, and again it will start decreasing. So it's getting decrease. And if you'll go for, if you will go for, suppose take like this. Yeah. If you will go for inductor, what is xc? 1 by 2 pi f into c, right? So at infinite
Maybe
frequency,
infinite.
at infinite frequency you will get the voltage value 0, right? V is equals to I into xc, and at infinite frequency you are getting 0. Now if you will decrease the frequency, the voltage will get increase, and at one point will come, that frequency will call, we call FC frequency. When it will be maximum, your capacitive frequency will be maximum, then it will again start decreasing like this. It will go like this. Okay. Now this is the graph for FC, and this is the graph for FL. When both this FC, when both this VC and VL will intersect, where it's intersecting, that frequency is known as resonant frequency also. So we draw the graph for VC separately, we draw the graph for VL separately in the same graph, and where they are intersecting, that point is known as resonant frequency. Is this clear? Guys, is this clear?
Yes, sir.
Or any doubt? Priyanka, any doubt?
Clear, sir.
Okay. So guys, draw the RLC graph diagram. R L, that is C. So this is R, this is L, this particular is C. Okay. So you have RLC. So what will be the current in this? V by Z. Okay. So V by Z you will get. So write the equation for, this is your voltage, positive. I am assuming this direction, I. So what will be the I value? V by Z. And how can we write this? R plus J
Plus L plus
XL minus XC. We can write like this, right? And what will be the voltage of VC voltage? VC voltage will be mod I into XC. And what is the VL voltage? Mod I into XL, right? So if you want to find the value of a VC, what is the mod I value? V divided by root under r square plus xl minus xc the whole square. xl minus xc the whole square. It is multiplied with xc. Right. So if you will take common, uh, if you want to take the common, so xc is what? V divided by omega c, right? V divided by omega c, and you have root under r square plus xl minus 1 upon omega c the whole square. Write this as a omega l. Omega l. Okay, for finding the maximum frequency, what you have to do with respect to omega? So dou Vc by delta omega, and you have to equate 0. And if you will equate this if you will do the derivations of this, means this is omega into c. If you'll solve this, you will get particular frequency fc, and that will be 1 by 2 pi root under lc under root 1 minus r square c divided by 2l. Okay, so that will be the means what graph we draw what particular graph we draw, that fc. So at what frequency we are getting the highest, means maximum voltage? Guys, are you getting what I am saying? Guys, are you getting what I am saying? Just wait. See, we drawn this graph. We drawn this particular graph. So we are actually finding this particular frequency and this particular frequency. We are finding fc and fl. So for that, what we are doing, we are taking IRLC, means RLC circuit is there, I is V by Z. So this I is going this side and it's having XL value, it's having XC value. Okay, we are talking about the magnitude part. So that's why we'll take the magnitude current. So magnitude current will be, I magnitude will be V divided by R square plus XL minus XC the whole square under root. So this is my I magnitude. So I having the magnitude current, and this magnitude current when multiplied with this XL will get VL value, and when this will be multiplied with XC value will get VC value. So I am doing for VC. So VC will be V divided by root under R square plus XL minus XC the whole square into XC. Okay. Now, and XC value is 1 upon omega C. So that's why omega C came. R square and XL value is omega L minus 1 by omega C the whole square. Now for finding the maximum value, we are finding the maximum value for what? We are finding the maximum value with respect to frequency. Okay, so that's why, and frequency, and how we get it. So that's why we have to differentiate with respect to dou Vc with respect to dou omega, because omega is 2 pi f. So this we can take it as a common. So that's why I am doing the differentiation with respect to dou omega, and I am equating it to 0. Okay, and when I will do the differentiation, when you will do the differentiation, what value you will get? So you will get something differentiation if you will do So this there is a no, so nothing is there, so minus v will come, and the differentiation of this particular, so c will come.
నిజమైనట్టుంది.
What? Hello.
Yes, sir.
So c will come, and plus omega c will be there, 1 by.
Sir, screen is not visible.
Oh, a screenshot is not visible. Okay, just wait. Is this visible now? Is this visible? Guys, is this visible? Screen is visible.
Yes, sir.
So, see what I am saying. You are writing I is equals to v by z, v divided by r plus j xl minus xc. Magnitude will be v divided by root under r square plus xl minus xc the whole square. Vc will be I into xc, and vl will be I into xl. Now we want to get the value, this particular fc value, means at what frequency we are getting the maximum capacitance voltage, and at what frequency we are getting the maximum inductor voltage. So for that I need to differentiate with respect to frequency, and I'm differentiating with respect to omega, because we have taken all the things and in omega. If you want to directly do with frequency, so write it down like this: 2 pi f l minus 2 pi fc, and differentiate here with respect to dou vc by dou fc. So you will get the highest frequency, means after differentiation and all, this will be a very long calculation. So you will get fc value is 1 by 2 pi root under lc root under 1 minus r square c divided by 2l. So this is a very important result, and for same thing you have to do for getting the result for vl. So for vl, what you have to do, vl is v divided by root under r square plus xl minus xc the whole square into xl. So v into omega l divided by root under r square plus omega l minus omega 1 by omega c, 1 by omega c the whole square, and here you have to do dou vl by dou omega is equals to 0. So you will get one fl value that will be 1 by 2 pi root under lc, and root 1 minus r will become, just wait, so your r will become 1 by
r,
the whole square,
L will become C,
and c will become l, and l will become c, and 2 will be 2. So these two formula you need to remember. Okay, so it's not a very big formula. This is your resonant frequency formula only. Okay, and you need to remember only one. If you remember one of this, then you can find the other one. So 1 minus r square c divided by 2l. So write it, means fc 1 by 2 pi root under lc, under root again will come, and you have to write 1 minus r square c divided by 2l. So r square c divided by 2l, and fl will be 1 by 2 pi root under lc root under 1 minus 1 by r square L, and this will be 2c. That's it. Up to here it's clear for everyone. So this is a very important result. Okay, this particular is a very important result, and you need to remember this particular formula, because in exam they will give you all the things. You will have L, you will have C, you will have R, and they will ask you at what frequency you will get the maximum capacitor voltage. At what frequency you will get the maximum capacitive voltage. Okay, so Prasanna, you understood this part. Priyanka, guys, I'm asking to you guys. Hello, guys. Guys, my voice is coming. Hello. Yeah. So just wait, means there is a network issue. Just wait. I'm giving you a different link in WhatsApp. Please join that link. Okay. Yeah. So So I was discussing this, means up to here uh, you got. So please tell me, I discussed this one, you guys got this result up to here? Prasanna, at what time the connections lost, just tell me. Priyanka, at what time the connection lost, just tell me. Means
FC equation, sir.
in FC equation, okay. So see, yeah, in FC equation, we are getting FC equation as 1 by 2 pi root under LC, 1 minus R square C divided by 2L. For FL, the same thing will be 1 by 2 pi root under LC, 1 minus R will become 1 by R, C will become L, and L will become C. So this is the things. Okay, so means in examinations now they can ask you find the value of FC, find the value of FL. So you have to use this particular equation and you have to remember this particular equation thoroughly. Okay. Okay, Priyanka. See,
Yes, sir.
and you understood now these derivations, how this coming, how this equation is coming. We have to equate dou vc by dou omega like this. Then only it will come. Okay. So then only this will come. So just revise this formula, means you need to mug up this formula, because if you will do the derivation it will take a lots of time for a differentiation. So this formula I will just tell you, this formula you just have to remember. Okay, for resonance this is very important. Okay, just wait. So this formula is very much important formula. Now see the further topics. We'll see the further topics. So make a short notes. In that short notes na, you have to incorporate this, you have to write this formula in your short notes. Okay, so that at the final examinations, means before the examinations, you can just see this result and you can implement in the examination. Or you can do one thing, means make a chart paper, write all the formula in a chart paper, all the short things, and paste on your wall. Okay, room wall, so that you can see every day this kind of formula, and you will be very familiar with this formula. So this is one of the method to remember this kind of formula, by seeing daily. And you can also see this formula daily by doing the revisions again and again. Okay, so yeah, now we are moving towards the tank circuits and all. Parallel resonance, yeah, parallel resonance is left. Okay, and something. Yes. Okay. Or guys, there is a one more method, uh, better to remember like this. Okay, if you know the capacitor formula, if you know this capacitor formula is 1 by 2 pi root under LC root under 1 minus R square C divided by 2L. FL can also be written like this, 1 by 2 pi root under LC root under 1 minus 1 divided by, take all things down, r square c divided by 12. This can also be, and if you derive this, you will get the same result. Okay, so if you know one of this, you can get the another of this. Okay, now write down the quality factor. What is quality factor? What do you mean by quality factor? So quality factor is what? Quality factor is, so any idea? Guys, do you have any idea about the quality factor? Prasanna, do you have any idea about the quality factor?
Yes.
It is the ratio. Write it down. It is the ratio of the maximum or peak energy stored in the circuit to the energy dissipated in circuit in one time period. Okay, so quality factor can be written as, quality factor is maximum energy stored in the circuit. So maximum energy stored in the circuit divided by energy dissipated in the circuit per oscillation, means one time period, per oscillation, or write it like this, per cycle oscillation, per cycle oscillation. Okay, so maximum energy is what? Maximum energy is 1 by 2 half Li square plus half C Vc square, means energy is stored across the capacitor, energy is stored across the inductor. Okay, and here I of t is Im sine omega t, and Vc of t is 1 by C I of t into dt. So you will get 1 by C integrations of Im sine omega t into dt. Okay, by solving this, Vc of t will come minus Im by omega c. Integration means, if you will do minus Im by omega c cos omega t value you will get. So yeah, so energy is stored, you need to find the energy, means maximum energy is stored. So half L Im sine omega t the whole square plus half C minus Im omega c cos omega t the whole square. So if you'll solve this, half L Im square sine square omega t plus half C, what's happened? Okay, my screen is visible right now. Okay, so half half c im square that is omega c. Okay, omega square c square into cos square omega t. Okay, yeah. Now you need to put the value of omega, and what omega value you will put? 1 upon root under LC. If you substitute 1 upon root under LC, omega is 1 upon root under LC value. If you will substitute, omega is 1 upon root under LC value. So omega square will be how much? Omega square will be 1 by LC. And if you will put, and this particular will get cancelled out, so omega square c, so you are getting omega square c value, omega square value is 1 upon LC, so you are getting half L im square sine square omega t plus half im square cos square omega t, and this is c into 1 by LC, so it will get cancelled out, so it will get half L im square, you will get common, half L im square you will get common, and sin square omega t plus cos omega square omega t will be 1. So see guys, what we did, we need to find the energy stored. So we have a two things in this circuit. Inductor is there, capacitor is there. Energy stored, energy across the inductor is half Li square, energy across the capacitor is half CV square. I of t is Im sin omega t, and Vc of t, the voltage across the capacitor, means you have inductor, you have capacitor, the current will flow, the same current will flow, and this is Vc. The energy stored in this will be half Li square, and the energy stored in this will be half CV square. So I just added both of them. I of t value I am taking Im sin omega t, so and Vc of t, we know that 1 by c integration I of t into dt. After solving the integration, I am getting the Vc of t value is minus Im by omega c cos omega t. Now I will substitute this value, and we are checking at omega is equals to 1 by root under LC. Okay, at resonant frequency we are checking these things. So omega m value is half L Im sin omega t the whole square plus half c minus Im omega c cos omega t the whole square. So while solving this, I am getting half L Im square sin square, this is square, this is not, this is sin square omega t. Okay, and this is half c Im square omega square c square cos square omega t. Now if omega is 1 by root LC, so omega square will be LC, so c square and c will get cancelled out, and omega square I am getting as a 1 by LC, and c will again cancel out, so this L will go upside, so you will get half L Im square plus common I am taking half L Im square common, half L, this L will come upside, so sin square omega t plus cos square omega t. So omega m energy, what you are getting, omega m energy, what you are getting, omega m energy you are getting 1 by 2 L Im square. Okay,
So can you show me the starting part of slide?
yeah, see.
Okay. So okay, so continue.
Okay, and here 1 by time period, so it will be multiplied with 2 pi. Okay, 2 pi will be there. Okay, so we are getting omega m is equals to half L Im square. Okay, now you want to find the maximum energy stored. Okay, so quality factor is what? Quality factor is 2 pi. What I told you, maximum energy stored. Maximum energy stored, what you are getting? Half L Im square. And total energy stored. Total energy stored will be 0 to T I RMS the whole square into R into dt. Means energy dissipated. See the ratio of the maximum. See this point very carefully. See this point. See, maximum or a peak energy is stored in a capacitor, okay, to energy dissipated in the one time period. Energy dissipated in one time period. So energy means 2 pi, automatically 2 pi will come. I will show you. See, so and where energy will be dissipated? Across the resistor, right? Across the resistor, because you have resistor, you have inductor, and you have capacitor. So energy was storing in this particular two parameter. Energy was not storing in the resistor. This inductor and this capacitor was energy. It's storing the energy in the form of magnetic energy and electric field energy. So we did the calculation for that. At what frequency? Omega is equals to root under LC. And all the energy, whatever it is stored, it will dissipate in resistor. So I am finding, and it is 1 upon time period. So 1 upon time period. So actually the time period is 2 pi. So this 2 pi will get upside. So that's why 2 pi is coming. Okay, that's why 2 pi is coming. Now if you will find the quality factor, you will get 2 pi 1 by 2 L Im square divided by I RMS the whole square into R into T. And T is what? T is your 2 pi only. So 2 pi into half L Im square divided by Im square into R into T. That is 2 pi. So this both will get cancelled out. And you will get Im square will get cancelled out. So what final result you will get? And I think I am missing something. Let me check. Yeah. Yeah. So this is IRMs na, and this is IM. So yeah. Yeah, this particular is your IM. See, this particular is your maximum current, and this is your IRMS. So you know the relation between maximum current and RMS. So IRMS is IM by root 2. Okay. Yes. So if you will substitute this value, so you will get 1 by 2 L Im square. This will get cancelled out, and Im by root 2 means you will get 2 square into R. So this will get cancelled out, this will get cancelled out. So what you are getting finally? You are getting L by R. Or suppose you are not means write in the standard form. I'm really sorry I'm doing like this. Write in the standard form. It will be good for generating the formula, because it will come in the terms of Excel. So this is 2 pi. Okay, this particular is your 2 pi. So if you'll do 2 pi to half LIM square, and we are getting IRMS. I am putting IRMS value is Im by root 2 the whole square. So I will get Im square into 2, and R into time period will come. I am not cancelling this time period. Okay, so this will get cancelled out, this particular will get cancelled out. I'm generating the formula, that's why. Now 2 pi into L divided by R into T. Okay, so 1 upon T is your frequency. Okay, 1 upon T is your frequency, so I am putting this upside. 2 pi F into L divided by R. This means omega L into R, that is XL by R. So this is the actual quality formula, quality factor formula. Prasanna, understood what I did? See, omega m is 1 by 2 pi Lim square from these derivations we got, and the quality factor, I told you it's energy dissipated. So energy dissipated in one time period. So one time period I'm taking as a 2 pi. So 2 pi is getting upside, and I'm deriving this. I'm assuming this t as a t because I have to form a formula. If I'll do it, I will get L by R. So it will not get be useful. So means the quality factor is XL divided by R. XL divided by R. Quality factor will be XL divided by R. Yeah. And same thing, yeah, same thing you can write. Hence XL quality factor is omega L divided by R, right? And if you want to write in terms of a capacitor, what will happen? In terms of a capacitor, if you want to, this is in terms of a inductor. So your in terms of a capacitor, what will happen? QC will be for parallel combination, you will get 1 upon omega RC. 1 upon omega RC you will get for parallel, because omega L will be equal to 1 by omega C, right? XL is equals to, we are doing for resonance frequency na, XL is equals to XC, means XL is omega L and XC value is 1 upon omega C. So instead of omega L value, if you want to write in terms of a capacitor, the quality factor will be same. This quality factor and this quality factor will give you the same result only. Instead of omega L, we can write 1 by omega RC. We are not doing duality here. It's actually the main formula for series network only. Quality factor is omega L by R, and this omega L, because we discussed earlier only, XL is equal to XC, so omega L is equals to 1 by omega C. So instead of omega L, I am writing omega C. So I am getting a quality factor as 1 by omega RC also. And there can be a lots of formula for quality factor. See, formula number 1, every formula will give you the same result only for a series RLC network. So one formula is quality factor is XL by R. XL means omega L by R. Quality factor is XL by R, that is omega L by R. Second formula for quality factor will be, because this is a resonant circuit, we are doing for a resonant circuit, so this is 1 upon omega C into R, because omega L is nothing but 1 by omega C. That's why we are getting omega is root under LC, resonance frequency. And another frequency, another how can we do? 1 divided by R into C, and you can write omega as a 1 by root under LC. So if you solve this, what you will get? 1 by R root under L by C. So all are same. This all quality factors formula are same. XL by R, 1 by omega CR, 1 by R root under L by C. Okay. And quality factor can also be written like this. See, quality factor, you are getting XL by R, right? If you will multiplied I upside and I downside, so it will give you which voltage? VL voltage. And I into R will give you supply voltage, because even you can better you can write not supply voltage, it's a resistor voltage. Okay, so VL by VR, and you can do the same thing also. Means Q is equals to, you can write XC downside and this is your R, multiply I upside and I downside. I into this, I into 1 by XC will give you VC value, and I into R is VR value. So this will also give you the quality factor. It's up to you how you want to get the quality factor. So from this we can write this a quality factor in a simple form. Quality factor, reactive component of voltage, reactive component of voltage to active component of voltage. Active means resistive component of voltage. Active component of voltage. Prasanna, understood this point?
Yes, sir.
Okay. So now write something at resonance. At resonance, your VR voltage is IR into R, and the current will be I into R only, and the value of I is V by R only, and R will get cancelled out. So your means at resonance, if you have R L and this as a C, and you have some particular voltage V, the voltage will come, same voltage will come here, because this will get cancelled out. So that's why, that's what I did. And your VL voltage is JXL into IL, that is, we can write JXL into I, and that we can write like this: JXL as a omega naught into L, and I as a V by R. Okay, V by R, and we can, yeah, so omega naught into L by R, this particular term was quality factor. So we can write like this: JQV. Same thing we can do for capacitive voltage. So for capacitive voltage, VC is equals to J XC into JXC into IC. This is your voltage, capacitive voltage, and minus will come, minus 1 by omega C, it's coming now. So these things can be written as minus J omega naught C. IC value is your I only, minus j omega naught c, and I we can write like this, v by r, and this was 1 upon this particular was your quality factor. So we can write minus j q v, vc value. Now is this clear to everyone? Prasanna, is this clear? Priyanka, is this clear? What it?
Yes, sir.
So see, it's not a very big deal, big deal. What we are doing, just remember the things, very small things you have to remember. What is the actual meaning of a quality factor? Maximum or a peak energy stored in a circuit divided by energy dissipated in a circuit in one time period. So maximum energy we find stored energy will be stored in where? Inductor and capacitor. Put the everything and derive the derivation, so you will get half Li square, half Lim square, and the energy will be dissipated across the resistor. So the formula is IR square into dt, 0 to t time period divided by time period. So time period will get this time period, we are taking its upside. Now after the derivations we are getting quality factor is XL by R. And what is the XL? XL is equals to XC, that is omega L is equals to 1 by omega C. Okay. So you got Q is equals to XL by R. So the same thing will be XC by R. So Q will be equal to XC by R, and the value of a XC is 1 upon omega C R. So we are getting QL is equals to omega L by R and QC is equals to omega RC. Okay, so quality factor formula we are getting XL by R. Quality factor formula we are getting 1 by omega, that is omega L by R, and 1 by omega CR, and we know the omega value is 1 by root under LC, because the quality factor is happening at the resonant frequency only. So 1 by R root under L by C also will get. Okay, and yeah, so this quality factor XL into I just multiplied I here and I here. Okay, so I just multiplied I here, and for capacitor also we did XC I here and R into I here. So XC into I is your VC and R into I is your V. Actually XC is 1 upon omega C, I by omega C is your VC. So you are getting VC by VR and you are getting VL by VR. So we can say that reactive component of the voltage divided by active component of the voltage, quality factor is, that is what? It is your reactive component of the voltage, and this is your active, means resistive component of the voltage. Okay, you have to take one parameter, either inductor or capacitor. Okay, now at response means at resonance, if you want to see, the voltage VR is equals to IR into R. So whatever the what is IR, this is your IR, this is your IL, and this is your IC, all are equal to I. So IR into R is equals to I into R, and I is what? V divided by Z, and Z is what? Z will be R only, because this two will be cancel out. So we'll get VR as supply voltage. So VR value we are getting as a supply voltage, and VL JXL into IL. And what is IL? I only. I is V by R, and we already discussed omega naught into L by R is your quality factor, so JQV, and VC minus J XC into IC. So minus J XC value is 1 upon omega naught C, and we already discussed this particular is your quality factor, 1 divided by omega naught C into R is your quality factor. So we are getting this. Okay, now the next topic is bandwidth. What do you mean by bandwidth? So bandwidth means what? It is the range. It is the range of frequency. Range of frequency in which the power level in the signal, in which the power level in the signal is at least half of the maximum power, is at least half of the maximum power. So suppose this is the I and omega graph. We already discussed in the class. The graph was like this, somewhat. Okay, it's like this. You are getting this particular at omega naught. Okay, this is your I max. I max, maximum current is possible at what frequency? Resonant frequency only. Resonant frequency. And I am taking this particular as I max by root 2. I max by root 2. And this is my omega 1 value, and this is my omega 2 value. So what is the meaning of your bandwidth? Bandwidth, you can see by definition, it is the range of frequency. Frequency range is coming from omega 1 to omega 2, in which power level is at least half of the maximum power. So maximum power is means, if you want to get the maximum power will be what? I max square into R. Okay, I max square into R. And so P by root under P by R at this value, this is your P max value, you are getting this particular current. If you want to make your power half, so I am dividing the power P by 2 at some particular current. This is my P max, and this is my I square, and this is my R. So at what current I will get P max value? Substitute the P max value, P max formula. So I max square into R by 2 is equals to I square into R. So this will get cancelled out. So I will get I max by root 2. So that's why I am taking some I max by root 2 current, and this I max by root 2 current will possible at some particular frequency omega 1, and we will get I max by root 2 current two times. One will be this side, means lesser than resonant frequency, and one will be greater than resonant frequency. Okay guys, so this is your bandwidth. what I am telling. We already seen the graph of this particular, I'm taking this particular point. So we already see the graph between frequency, this is my frequency, this is my current. So at what current I am getting this as a maximum value? The maximum value possible, because I is equals to V by Z, and if this will be low, then we'll get the high current. And at what value it will be low? When you are having the omega naught frequency. So this is my omega naught frequency. And what will be the power of this? If my current is maximum, so I will get maximum power. Maximum power, my P max will be equals to I max square into R. Okay. So this is your maximum power. Now what they are asking now, the frequency, the range of frequency where you are getting at least half of the power. So at least half of the power means I'm taking my P max by 2 value. Okay, and I am assuming different current, because I max is possible at omega naught frequency, and different current we don't know at what frequency the different current will get the maximum power. So I am taking some I value, some random I value, I square into R. Okay, now I am substituting this I max square. I max square into R by 2 is equals to I square into R. So if I'll solve this, I will get I value as I max by root under 2. I max by root under 2. So suppose I am getting this. Here I am getting that I max by root under 2. So these particular graphs are identical, symmetrical. So 2 value will come. Okay. So here also you will get I max by root 2. So I am assuming this is my omega 1 and this is my omega 2. So the range between this half, this is the half power what we are saying, half maximum power. So the range between these two is known as your bandwidth. Is this clear, guys? Prasanna, is this clear?
Yes.
Understood. Okay. Now you need to find the value of omega 1 and omega 2. How you will find this omega 1 and omega 2? How can you find this omega naught, omega 1 and omega 2? See, it's very easy. It's not very difficult. We got a relation. What relation we got? I is equals to I max by root 2, right? And we have a circuit. This is R, L and C. This is my V value. So I max is occurring at resonant frequency. So I am writing V is equals to I into Z. V is equals to I into Z, and it's occurring at a resonant frequency, so we will get only V into R by root 2. Right, Prasanna? Because this will get cancelled out. It's occurring at a resonant frequency, so we'll get only R value. But for this, we will get Z value. No R value will come. So V into R by root 2. So it's getting cancelled out. So R is equals to root 2 into Z. And you need to find the value of omega. So R is equals to root 2, root under, take R square plus XL minus XC the whole square. Okay, now you need to solve this equation. So you will get r square plus 2 r square plus plus that xl minus xc the whole square. So xl minus xc the whole square, you can write omega l minus 1 by omega c the whole square. Okay, so by solving this you will get r square plus omega square l square minus 2 omega l into 1 by omega c plus 1 by omega c the whole square is equals to 0. Right, so this particular will get cancelled out. R square plus omega square l square, this will be minus 2 l by c plus 1 upon omega c square. Now for solving this, now take omega square is equals to x. So r square plus xl square minus 2 l by c plus 1 by x c square is equal
X is squared.
to 0. So make the okay, take the LCM and solve it. So L by C is there, so take xc square as LCM. So what you will get? X c square
C
r
square,
square
R square,
plus
L square, C square,
x square l square c square minus 2 l c is there. So xc will come plus 1 and it is equals to 0. So you are getting x square l square c square plus x, take x as a common, you are getting c square r square minus 2 xc plus 1 is equals to 0. Now if you will take l square c square outside, so x square plus x as a common, c square r square minus 2 xc into 1 by l square c square plus 1 by l square c square is equals to 0. Now yeah, yes, so this is the from this you can get the value of your x value. Okay, x value will be minus b, so minus c square r square minus 2 xc divided by l square c square plus minus root under b square minus 4ac. So do b square minus 4ac divided by 2a, and when you will get this value you have to take the root, so you will get one plus value and one minus value. So you don't need to do, I just tell you the way how we are getting this formula. Okay, how we are getting this formula. So you don't have to remember these things, you just need to remember the bandwidth formula is nothing but wait, okay, write it down. So bandwidth formula, bandwidth means this is your omega 2, this is your omega 1. So what is the distance between these? Means bandwidth means omega 2 minus omega 1. So by doing the approximations and all, you will get the formula bandwidth is R by L, resistance by inductor. That's it, radian per second. And if you want to find the value of omega 1 and omega 2, if you want to find the value of omega 1 and omega 2, so write it down. Formula for omega 1 and omega 2 will be it will come, see, I'm taking, this is my omega naught value. Okay, this is my omega naught value. So if I want to find the value of this particular omega 1, so you need to do, and I am assuming this is my omega naught by 2 value, and this particular is my omega naught by 2 value. So what will be the omega 1 value will come? Omega 1 will be bandwidth omega naught minus bandwidth by 2. See, I'm giving you a simple explanation. This is your curve. This particular is your I max. This is your I max by root 2. That means I am having a omega 1 value here and omega 2 value here. Bandwidth means total distance between this. That is omega 2 minus omega 1. So bandwidth is nothing but omega 2 minus omega 1. That approximate value we will get R by L by solving the equation. By solving this equation, but it will be a very huge equation. If you solve this now, it will be a very huge equation. So no need to go for these derivations. You just directly write bandwidth is R by L. But this is my bandwidth. This is my bandwidth, means a distance between this particular. And we are taking R by L will give you a radian, okay, not hertz. Always remember. So this is my bandwidth. So I am taking means and I know this particular frequency is my omega naught. Okay, omega naught. So assume half bandwidth this side and half bandwidth this side. Okay, so just do omega naught. If you will, if you have a omega naught value from 0 to this as is your omega naught value, and this particular is your bandwidth by 2, so you want to get the omega 1 from here to here, what you will do? Omega 1 will be equal to how much? Omega naught minus bandwidth by 2, and omega 2 will be how much? You have here to here value is bandwidth by 2, and you want to get the value of omega 2, means omega naught here to here value, from 0 to here value, this is your omega naught value, and if you will add this bandwidth by 2, you will get omega 2. So omega naught plus bandwidth by 2. So this particular is your frequency formula, and bandwidth I already told you, bandwidth is R by L, and omega naught value is root under 1 by root under LC. And yeah, and omega naught value, if you want to get the omega naught, means omega naught value is also omega 1 plus omega 2 by 2. If you'll do add this plus this, what you will get? This will get cancelled out, 2 omega naught will come, omega 1 plus omega 2 by 2. Is this clear, guys? Prasanna, is this clear, or you want say any explanation?
Got it, sir.
is means it's not clear.
It is clear.
It's clear now. So see, so omega naught value we are getting, but this is the approximation result r by l, because we are getting a huge number like this. Okay, so this is your approximate results. Okay, so this is for your approximate result. So and bandwidth can also be written as, bandwidth is also written as omega by q, omega by q. Okay, and if you want to this bandwidth, it is for radian. If you want to take it for hertz, then you just have to divide by 2 pi. Means bandwidth we got r by l, it is for radian. If in the questions they are asking for hertz, what you have to do, what you have to do, r by
Divide with 2
2 pi, that's it. Same for omega 1 and omega 2, get the result like this, then divide it by 2 pi, omega naught plus bandwidth by 2 and then divide it by 2 pi. Okay, so note it down. For a higher quality factor, for a higher quality factor, the resonant frequency is approximately equal to the arithmetic means of the upper and the or leave that one. Means we'll discuss these things tomorrow, so leave it today. And one thing I just want to tell you, one more thing. Always means there is a 3-4 approximation. Omega 1 into omega 2 is equals to, we are assuming it as a omega naught the whole square. Okay, omega 2 minus omega 1, it is your bandwidth. Okay, and omega 2 plus omega 1, it is root under omega 2 minus omega 1 the whole square plus 4 omega 1 omega 2. If you don't remember this formula, it's also fine, but you need to remember this formula. This was the story of series resonance circuit. Now you have to do for the parallel resonance circuit. For parallel resonance circuit, we don't have to derive anything. By the use of a duality, we can get all the things, all the results. So we'll see the parallel resonance circuits tomorrow, and there is a tank circuit and dynamic impedance, and dynamic impedance is the last topic. Then we'll move for the last part of the chapter, graph theory. Okay, so see, means just go through it, just do by yourself. Okay, means bandwidth is what, r by l. Okay, write in your notebook and just revise the things properly. But when we'll solve these questions now, so then you will understand means why this is r by l. Okay, so just revise it and just yeah, just revise the topics very seriously, then the things will be very clear for you. Okay guys, so we'll meet tomorrow. Have a good night.